So we have defined continuity for a particular point. Okay. Similarly, we can also define continuity for a particular interval. So maybe if you have an interval like this, that is a closed interval AB. Okay. So always when you consider continuity, the closed or open. Okay. You should be very specific over there. If it has to be closed, that means that at that particular point also it is going to be included. If it has to be open, that means that that point is accepted from that given condition or the given function. Okay. So now we have for a particular interval and we have f of x. Okay. So f of x is said to be continuous at this particular interval if it is continuous at every point. Okay, that's all about the definition. There's nothing much to think about that. So if you consider a graph like this, okay, graphical form, so it should be continuous. Okay, there should not be any break in between. Okay, that's all about the geometrical representation or the geometrical understanding of what is the meaning of continuous. See, if we consider this point, it is hollow. Okay, then this function cannot be called as continuous. So if you have a straight line, it is continuous. Okay, if it is continuous, if this line is continuous, that means that function is also continuous. Okay, that's all about meaning of the function to be continuous. Now we'll think based on this what are going to be the results now. So we'll think about the different types of functions. So in the last year in the chapter straight lines, we have learnt about the first type, that is a constant function. Okay, constant function is having a graph that is in the form of y is equal to k, that is a horizontal line. Okay, only that thing from the chapter, horizontal line. So it is a constant function. So when you consider the function, it is also always y is equal to something. So it is going to be a straight line that is parallel to the x-axis. So it can be up or down depending on the sign. So I am considering it is going to be up. So we'll think about the constant function. Constant function can it be continuous or it is not continuous, discontinuous in other words. So if you consider this is a straight line doesn't have any breaks in between, right? Therefore every constant function is continuous. Okay, if you consider any line, every constant function, it is going to be a particular line that is a parallel horizontal line itself. Therefore every constant function is continuous. So I need not think much about that now. Next we'll go to the second type of function. Okay, we learned in the last year's chapter relation of functions, that was the polynomial function. Okay, what is the form of a polynomial function is always a0 plus a1x plus a2x square plus so on. Okay, maybe whatever is the thing depending upon a1, a2 and a0, it can be classified based on the polynomial, which is polynomial, cubic, blah blah and so many things. So what it is going to be is a very long term. Okay, so whenever you consider a function, so first of all this is a constant function if you remove all the other factors. So constant function, we know it is continuous. Now we'll take the second term, it is going to be linear. Okay, linear expression. For a linear expression, we know that it is going to be a straight line. Therefore, straight line is also continuous based on this one itself. Now, if you consider this x square term along with this, it is going to be a quadratic one. If you consider a quadratic, it is going to be a parabola, right? It is going to be parabola. Similarly, you are going to get x cube also. X cube is double. You will get somewhat like this. So that also you can say that it is going to be a continuous only. Similarly, this goes on repeating. The number of turns goes on repeating based on the number of extra terms more than the linear terms. Okay, that's all about this. Therefore, you can infer from this that this is continuous. Okay, this is going to be the continuous function. So So now we understood that every polynomial function is going to be continuous. So if you are asked to show that a particular form is given in a question, like f of x is equal to 2x plus 3, show that it is continuous. You can just tell that f of x is a polynomial function, therefore it is continuous. Okay, that's all about the polynomial function. Next we'll think about rational function. That was the thing we learned in the rational function. What is a rational function is, it should be p of x divided by q of x, where q of x is not equal to 0 and both p of x and q of x are polynomials. Okay, they are polynomial functions or simply polynomials. Okay, this is a rational function. This should be equal to, it should be in this form. So since if we divide a continuous function divided by another continuous function, we always get a continuous function. Okay, that's all about what we learn from this, that it is a continuous here also. Okay, next we are thinking about trigonometric functions. Trigonometric functions. If you consider the trigonometric functions, you can see that the graph, if you consider the graph of tan, if you consider the graph of sec, okay, sec, cosec and those inverse functions, also you can find that they are not going to be joint. Like I'll show an example. So if you have sec function, the sec function comes like this in the between. Okay, but when you consider at this point, there is nothing. Okay, so what can we tell about the continuity of the trigonometric function? We can tell that trigonometric function is continuous only in its domain. Okay, so the trigonometric function, this if you consider the sec function here, its domain is not including these points. Yeah, right, this dotted lines and all, the places where it is not defined, that is, it doesn't have the domain containing these points. Okay, therefore in its domain it is continuous. Okay, you should be very careful while writing the sentence here, that is, trigonometric functions are continuous in its domain. Okay, many times if you leave this in its domain, when it comes to the tan function, okay, tan function is not defined when sign is 0. That means that at that point you are telling that it is going to be infinity, 1 by 0, and it is not going to be any number over there. How can it be continuous in that position? So the letter, so the phrase that is in its domain is very important here, in its domain. Okay, that's all about trigonometric functions. Next, we'll see what extra functions we had learned in last year's second chapter. That was the modulus function or the mod function. Modulus function, how we represented it in the form of like this, inside something also. Okay, modulus of something. So when we consider the modulus function, we'll see the graph of that. Okay, graph of a modulus function is a V-shaped graph that is intersecting at the point 0. Okay, if you consider the modulus value of x only. If you consider x minus 3, x minus 4 and such things, the V, that is the turning point, changes. So we are not going to think about that. Somewhere one of the point, especially on the x-axis only, it is going to be converging these two lines. Okay, so what do we think about this? Should be continuous. So this part is a straight line, right? This part is a straight line. What about the point over there? The point over there is continuous. Okay, because it's the meaning of the continuous is you can draw the graph continuously. Okay, you need not lift your pen again. I have drawn one after another, but when you draw the graph, it is like this, right? You are drawing it together. So it is continuously drawn. In other words, you can just understand that if this point is also continuous, therefore the modulus function is continuous in its domain. Okay, here in this domain is not important because or the domain is is applicable over here. Okay, next we'll think about this greatest integer function. Greatest integer function, GIF. This is the common thing we have used, and the notation of this is greatest integer function, greatest integer less than or equal to the x. Okay, so I hope you remember the graph of this. I'll just rub this off and just show you the graph, how it looks. The graph of a greatest integer function is a step graph. So always it comes like this, right? Like this, like this. So it comes in the form of a step. That means that one of these is round and filled, and another one is hollow. Okay, I think it's the opposite one. Yeah, it is filled here, and here it is hollow. Here it is filled, here it is hollow. In this form it is going to come in the form of a step. It's not proper. Somehow you are going to get this step graph. Okay, so when you consider these integral points, the value of the function just very little before this. Okay, let me consider the point 1 here, point 1. So I'll just show how it is using the method itself. Limit of extending to 1 minus of the greatest integer function x. Okay, then you have the function itself, that we leave that. Now we'll think about the right hand side, that is x tending to 1 plus greatest integer less than or equal to x. Okay, this much we got. So it is 1 minus here. That means it is a number which is very near to 1, but it is less than 1. Okay, in such a case, the number that is less than or equal to that thing is going to be, okay, it was alright like this. Okay, we'll just think about this part of the graph, that is at this point when it is 0, it is 0. When it is considering 1, it goes to 1. Okay, so when it is very near to 1 but less than 1 is going to be 0, the greatest integer function of that. Then if you consider this part, that is it is just very near to 1 but little bit more than 1. Okay, then it comes to this part, that is the value is going to be 1. Okay, this is the left hand limit, this is the right hand limit. So for proving that it is not continuous, you can just give a counter example. So this is a counter example that I have given here. So for this I can tell that it is discontinuous at integral points. So we can find out that only at this integral points, right? At these integral points only we can find out that it is going to be discontinuous. If you consider somewhere in the middle, it is going to be continuous. There is no problem with that. So if you consider only the integral points, it is discontinuous. If you consider a point in between here, it is going to be continuous. I hope you understood. That's all about the results of this thing. So we'll learn a little bit more properties now, then move on to one of the questions and then to the exercise. Now we are going to start with this. So we have the condition, that is if f and g are continuous. Okay, this is just a theorem. The proof is given in the textbook and I'm not bothered about that. It is not going to be so important also. So you need to just know this property to just show that it is continuous. Okay, so what about f plus g? F into g and f by g, then f dot g. Okay, these many properties or these many types of operations I know. These are common types of operations which we use. This is plus or minus. I included both addition and subtraction. This is the multiplication and this is the division. Okay, now we are just telling using this. There is a theorem given in the textbook. It tells that if f and g are continuous, then all these functions are going to be continuous. All these are going to be continuous. Continuous. Okay, I think some spelling wrong mistake. That will be now there is one more thing, that is f by g. F by g, it should be g not equal to 0. Yeah, there is one condition extra we are going to add here, because it is in denominator. We are bothered very much about the denominator, that is g should not be equal to 0. Okay, now we'll have an example question. We'll see example 2, I think. I'm just going very fast. That is f of x is equal to x square is given. Okay, you are just asked to prove. It is given examine. Examine means you just check whether the function is continuous at x is equal to 0. Okay, how do you check that it is going to be continuous at 0? Based on the function. Okay, at a point, the function is going to be continuous if its left hand limit is equal to right hand limit is equal to the value at that point. Okay, mainly we are bothered about either any two of those. Whenever the question arises, we have to find out LHL, left hand limit, right hand limit, and the value of that thing at the particular point. So it is, when you tell about the equation, you have only two sides, right? So we are going to opt only two out of those. So many a times it comes to be left hand, any one of the hands, and this one, that is the function. So in this case we have to examine, that's why we need to find all the three and tell that they are going to be equal or not based on it. So we'll think about the left hand limit. Left hand limit is equal to limit x tending to 0 minus x square. Okay, so this is very simple. When it is very near to 0, the value of the square also becomes very near to 0. That's all we need to substitute. 0 square is equal to 0. RHL is equal to limit x tending to 0 plus of x square. When it is very near to 0, the square also comes to be very near to 0. Again 0. Right? Now we think about f of 0. That is 0 square. Wherever x is there, we are substituting 0. This becomes 0 square or 0 itself. Since LHL is equal to RHL is equal to f of 0, that means that therefore f of x is continuous at x is equal to 0. I'm just scribbling something. That's all about the example 2. Now we'll move on to one of the interesting examples, or we'll go to the exercise. Okay, now we're going to start with one of the questions, that is find all the points of discontinuity for f of x is equal to that thing. Okay, this is given, that is x plus 2 when x is less than 1, 0 when x is equal to 1, and x minus 2 when x is greater than 1. Okay, there are three functions, three parts of the functions. So we can just imagine how it could be. So we'll see how it could be. Yeah, we have certain intervals now. Intervals when x is less than 1, that is one interval. Another interval is when x is greater than 1. Okay, those two intervals we have. Then we have one point, that is x is equal to 1. Okay, we need to just think about those three things. So first of all, we'll think about when x is less than 1 and x is greater than 1. Okay, then when x is less than 1, it corresponds, f of x becomes equal to x plus 2, which is a linear expression. A linear expression, or I can tell a polynomial. Okay, therefore this part or this interval is going to be continuous. Okay, when it is x is less than 1, I just mean that it is from minus infinity to 1, where 1 is not included. Okay, similarly when I tell x is greater than 1, I mean 1 to infinity, where 1 is not included. So now f of x becomes equal to x minus 2 according to the given question. So this is also a linear polynomial. Yeah, linear polynomial. Therefore this is also continuous. Okay, that's all about this part. Now we have only one point remaining. So the question is find all the points of discontinuity for this given function. So the maximum thing that can be discontinuous at the given function can be only one, because these two are already continuous, and all the points in this are going to be continuous because it's going to be linear polynomial. Okay, now we'll think when x is equal to 1. For that we need to find left hand limit and the right hand limit. Okay, if we want, we'll find out the function value. Function is already given, I think, so maybe we need not find that. We find f of 0, f of 1. Okay, left hand limit is limit x tending to 1 minus x plus 2. Okay, when x is less than 1, x plus 2 is a given function. Therefore, this function should be corresponding to this. Therefore, when x is corresponding to 1 minus, that is something which is very near to 1 but less than 1, that will be equal to 1 plus 2. That is going to be equal to 3. Okay, but the function f of 1, that is the value of the function at the particular point, is going to be equal to 0. Alright, that is according to the given question. So left hand limit is not equal to, therefore x is equal to 1 is point of discontinuity for f of x. Okay, that's all we concluded. Now we'll see what we have done now, because the steps are very important over here. So based on the given question, we divided this given function into 3 things. The 2 things were the interval and one was the remaining was the point. So the 2 intervals were based on the given thing only, condition only. So when x is less than 1, we have this condition where it is going to be linear polynomial, hence this function at that interval is going to be continuous. Now we consider another interval which is x greater than 1. Since that is also a linear expression, but it is not the same, I am not bothered, but still it is a linear expression, it is going to be continuous. Okay, that must be found out. That's all about the 2 intervals. Though we think about this thing and we found out that it is going to be discontinuous, we thought only about the function, the value of the function at that particular point, and the left hand limit, that is going to be x tends to minus 1, I mean 1 minus x plus 2. We are going to substitute 1 directly because there is nothing problem. So I hope you know how to use the limits and all, because some of the problems will be based on the last year's results. Okay, we'll see when the question comes. Okay, so we got LHL is equal to 3 and f of 1 is equal to 0. That means that left hand limit is not equal to the function. Okay, one thing is enough. After that, need not find the right hand limit and all. We can just directly tell that x is equal to 1 is a point of discontinuity, or f of x is discontinuous at x is equal to 1. Okay, that's all about this example question. Next we'll move to the exercise. Okay, now we have our exercise 5.1. In the first question it is given, prove that the function f of x is equal to 5x minus 3 is continuous at x is equal to 0, x is equal to minus 3 and x is equal to 5. Okay, x is equal to 0 is the first case. So when you consider x is equal to 0, since it is a linear function, the left hand limit also should be equal to the right hand limit. So I need not bother about finding 2 limits. One limit is more than enough. That is limit x tending to 0, 5x minus 3 is going to be minus 3. Okay, then what is about f of 0 is going to be 5 into 0 minus 3, that is again minus 3. Therefore continuous at x is equal to 0. Okay, which have x is equal to minus 3. Similarly, you are going to do the same thing blindly. You can even write what is there, 5x minus 3. So 5 into minus 3, that is minus 15. Minus 15 minus 3 is minus 18. Therefore f of minus 3 is also equal to minus 18. Therefore continuous. Okay, nothing to do. So while doing only, you need to be careful. That's all about this. Now we have limit x tending to 5, 5x minus 3, that is equal to 25 minus 3 or 22 I can write. So it is going to be f of 5 is equal to 22. Therefore, this is also continuous. Okay, that's all about this first question. So I hope you understood how to do this. Because you know to do the limits and all, I am going faster here because the later part of the calculus requires more explanation. Okay, I hope you understood the limits. Next will about the second one. Second question is given, you need to examine the continuity of the given function at x is equal to 3. So you have to find whether it is continuous at x is equal to 3. So the function given is 2x square minus 1. So for that I need to find the limit x tending to 3, 2x square minus 1. Because it is a polynomial function, I am not taking the left hand limit and right hand limit because both are going to be equal. So now we have 3, 2 in, this is going to be 18 minus 1 or 17. Similarly, f of 3 is also going to be 17. Therefore, continuous. Okay, that's all about the second question. Okay, next you have the third question. The question given is examine the following functions for continuity. So again we need to see about continuity. What is continuity in this case? So here directly are given. So based on the results, that was the 6th result we had used, that is the constant function, polynomial function, trigonometric function, rational function, modulus function, and the greatest integer function. Those 6 things we had used. Along with that, we have also learned about the theorem, that is f plus g, f minus g, f into g, f by g, and f dot g. Okay, those two composite functions and the operations and all we have found out. Based on that, we are supposed to prove that whether it is not prove, examine whether it is going to be continuous. So this most of the things, mostly it is continuous because they are directly given and you cannot go on find the value because it is considering to be the domain the whole real numbers. So now we have x minus 5. X minus 5 is a linear function. So since it is a linear function, so it is a polynomial, right? Linear polynomial. Therefore, directly can tell it is continuous, right? I am not writing everything. I am just explaining by mouth itself. So that's all about the first question. Because it is a linear function, linear polynomial, it is going to have a straight line graph. Straight line graph says that it is a continuous function. Next you have b, that is f of x is equal to 1 by x minus 5. Okay, here it is given that x is not equal to 5. That means that there is no position where this function is going to be infinity or it is going to vanish at a particular place. So when you consider this type of function, somewhere it is going to be in this form, somewhere like this. It is a curve. Since it is a reciprocal function, it is going to be a curve. I'm just giving an example over here. So what it happens here, mostly it is inverted like this, not like this only. It has to be somewhere like this. So from this, when it is not equal to 5, this function is going to be continuous, right? If you consider the point x is equal to 5, at that point it is going to be discontinuous. Okay, since 5 is excluded from the value of the domain, so you can consider that it is going to be a continuous function. Or in other words, if I explain, this is a rational function. F of x divided by g of x, where f of x is a constant function and here this is a linear function. Okay, constant divided by linear is going to be a rational function. If it is a rational function, when this denominator is not equal to 0, the rational function is going to be continuous. Based on that explanation, I just told that it is going to be continuous. Okay, next we have the C. In this question, this is f of x is equal to x square minus 25 plus divided by x plus 5, and x is not equal to minus 5. Okay, so just by seeing this, you have a tendency to cancel off because it is a square minus b square divided by a plus b form. Okay, it is given in that form, but there is no requirement of cancelling off all those things. You can just directly tell that it is a rational function. A rational function which has a numerator and a denominator. Numerator is a quadratic polynomial, while the denominator is a linear polynomial. And the denominator, the point where it is going to be equal to 0 is excluded. Okay, those three conditions only. Therefore, it is going to be a rational function here. Okay, this was the rational function. Both this and this. This was a linear, right? So this is also going to be continuous. Now the last thing is all about the modulus function. So the trick here is always a modulus function, whatever may be inside this, it is going to be a continuous function. Because the turning point changes based on the given extra term, that is minus 5 plus 3, whatever it could be. So whatever it is, only the turning point changes. That is, we know that it is a V-shaped graph. It is a V-shaped graph. So even if you put the minus sign outside, it's going to be inverted. That's all about the problem. So if you consider whatever is there inside the modulus sign, it is going to make this function a continuous one. Therefore, this is also going to be continuous. Okay? So since it is a V-shaped graph, we know that it is a continuous function. Based on that, we just explain that this f of x, there is a modulus function, is going to be continuous here. That's all about the third question. Moving on to the next ones. Now we have the fourth question. Fourth question is very simple. It is asked to prove that the given function, that is x raised to n, is continuous at x is equal to n, wherein there is a positive integer. So what are we going to do here? So x raised to n is a polynomial function. Therefore, the left hand limit and right hand limit is going to be equal, and you need to find the value at the particular point. So now we'll find the limit x tending to n, x raised to n. So this becomes n raised to n. Okay, similarly, f of n is going to be n raised to n. Okay, therefore the left hand limit is equal to right hand limit is equal to the given the value of the function at that particular point. Therefore, it is going to be continuous. That's all about this. So you need to write proper statements and all. I'm skipping all the statements. So now the next part is f of x is equal to this function. Okay, this is the given function. It is asked, is the function defined by this given thing is continuous at x is equal to 0, x is equal to 1, and x is equal to 2. Those three things I have written over here. Okay, so first of all, we'll find at x is equal to 0. Since x is equal to 0, the limit x is equal to 0 is same as x, therefore it is going to be 0, and f of 0 is also equal to 0, therefore it is continuous. Therefore continuous. Okay, next we'll think about x is equal to 1. So when x is equal to 1, so when x is equal to 1, yeah, limit. Since it is having two conditions, before and after, the left hand limit is not going to be equal to the right hand limit. Okay, so I'll find out the right hand limit and find the value at that particular point. So the right hand limit is x tending to 1 plus then 5. Therefore, it is going to be equal to 5. So this corresponds to a constant function from x is greater than 1. Whenever x is greater than 1, the function is going to be constant. Okay, that much thing we understood. That is used while finding the second part. So now we'll think about the function f of 1. F of 1 is equal to how much? So f of 1 is considering this, that is when x is equal to 1, so it is going to be equal to x. So what is x? X is 1 itself, therefore it is going to be 1. Therefore it is discontinuous, or I can tell not continuous. Okay, something. I'll just pull that. So 5 is not equal to 1. I know that 5 is not equal to 1. So therefore it is going to be discontinuous. Next we'll think about x is equal to 2. X is equal to 2 is a point in a given interval when x is greater than 1. Or I can consider the interval when 1 to infinity. 1 to infinity is a particular interval, and in that interval x is equal to 2 is one of the points. Since it is a constant function in the interval 1 to infinity, I can tell that being a point of a constant continuous function, x is equal to 2 is a point which is continuous. Okay, even without doing this, I can just explain based on that. Or you can do the same method there also. I'm not going to do that method now. So I'm just telling in another manner. So this is a constant function. Constant function is always continuous, that we know already. Since this is corresponding to the domain, the interval when it is 1 to infinity. 1 to infinity, this belongs to the interval 1 to infinity, where f of x is equal to 5. Okay, in this interval, this belongs to that interval, therefore it is going to be x is equal to 5. Since it is a constant function and x is equal to 2 is a point in that interval, x is equal to 2 is a point which is continuous. Okay, and using the converse of the thing which we used to define that an interval is going to be continuous, I just use the converse of that. Okay, next we'll think about this sixth question, f of x. F of x is equal to 2x plus 3, 2x minus 3 when x is less than or equal to and x is greater than 2. Okay, the question is find all the points of discontinuity of f. So, points of discontinuity. So, the question we have done is the second one based on that. So, second question, what we had done is dividing it into intervals and the points in which is overlapping between the two intervals. Okay, we are going to think about that. So first of all, when x is less than 2 and x is greater than 2. When x is less than 2, it is 2x plus 3, and when x is greater than 2, it is going to be 2x minus 3. Since both are linear polynomials, both are going to be continuous. Okay, I'm not writing the proper statement, you can just write the statements. So first of all, I got this. Now at x is equal to 2 is the remaining thing. Most probably it is not going to be continuous at this particular point. So many a times that only arises as a point of discontinuity. So we'll find the left hand limit, that is x is equal to limit x tends to 2 minus. When it is less than this, it's going to be 2x plus 3. Or let me take the right hand limit. Right hand limit becomes 2x minus 3. Okay, 2x minus 3. So I have to substitute, since it's direct. Substitute this, it is going to be 4 minus 3, that is 1. Okay, now the value of f of 2. F of 2, when x is equal to 2, it goes to the condition. This is the first condition. That means that I need to substitute a 1 in place of x. So it is going to be 2 in x plus 3, that is 5. Okay, since the value at that particular point is not equal to the right hand limit. Okay, therefore at that particular point it is discontinuous. Oh, I'm writing a manuscript. Something. It is continuous. It's all about the sixth question. Next, moving on to the remaining questions. Okay, now we have a seventh question. Seventh question is given like this. So, whenever you consider, here I can see that it is going to be everywhere. All the three are going to be the functions which are continuous. Okay, since they are a polynomial and f plus g and this is a modulus and those things, I can just tell that it is going to be it is going to be the value, that thing itself. So the problem arises to find out the discontinuity only at the points where the ends of the intervals occur. So the ends of the interval occur at -3 here, then 3. Okay, those two are the points. That's why I have it here. Okay, I hope you have understood. So there is no requirement of writing every interval that it is continuous. So you can just write these two and just conclude this. So x is equal to -3. We can find the left hand limit and the right hand limit and the point. And the point is not required because it is given one of them is same. That is, left hand limit is going to be same in that case. Therefore, I can just prove that left hand limit is equal to right hand limit and tell that it is continuous or not. So the left hand limit is going to be limit x tending to 3 minus, it is going to be modulus value of x plus 3. Okay, the modulus value of x is going to be 3 itself, so 3 plus 3 is going to be 6. What is right hand limit? That is limit x tending to -3 plus, that is -2 into x, that is -2 into -3, that is going to be plus 6 only. Therefore RHL is equal to LHL is equal to f of -3. Here I write f of -3 is also equal to 6. Therefore, it is going to be continuous. Okay. Next, you have x is equal to 3. So, we'll have the left hand limit, that is limit x tending to 3 minus 2x. Okay. Substituting x to be 3, which is going to be minus 6. Then we'll think about the right hand limit, that is limit x tending to 3 plus, then we have 6x plus 2. Okay, 6x is 6 into 3, that is 18. 18 plus 2 is 20. Therefore, it is discontinuous. Or I can tell that it is a point of discontinuity. Okay, now we have our 8th question. Let's see what is the 8th question. Since this is x is not equal to 0. That means that it includes the whole r, that is the real numbers, except 0. That means both the sides of the number line, except the point 0. At the point 0, it is going to be equal to 0 only. So we'll think when x is not equal to 0, that is the denominator is not equal to 0, this will arise with two conditions. Okay, how it is going to be defined? The smallest value of x divided by x. So similar question we have here also. We'll see what is the difference between these two. Okay, now if I need to tell this, it should be x less than 0 and x should be greater than 0. I need to tell it in two different ways because it is positive, whether it is positive or negative. If x is positive, the modulus value of x becomes x only. Okay, when x is positive, x modulus value of x becomes x only. So this expression becomes x divided by x, that is 1. Okay. Then we have when x is negative. When x is negative, the modulus value of x is going to be minus x. Okay. Therefore, this expression is going to be minus x divided by x, or it is going to be minus 1. Okay. I'm just telling you vocally only everything. So when x is positive, the modulus value of x is x only. Therefore, x by x becomes 1. When x is negative, it is going to be minus 1 because the modulus value of x, when it is negative, it is going to be minus x. Therefore, minus x by x is minus 1. Okay, that's all about this thing. Now we need to focus on the point of discontinuity. Since those two are the intervals and the border of the interval, okay, or the extremity of the interval is coming to be 0 only. Okay, in both the cases, we are not going to consider infinity, however. So it is going to be x is equal to 0 only. So we'll consider about the left hand limit and the right hand limit. Just by seeing, we can tell that the left hand limit is going to be minus 1, right hand limit is going to be 1, and the point is going to be 0. Right? We have not done anything. We have just expanded this part and just proved without even writing any step now. I'll just tell what we need to write. That is left hand limit. We need to write that expression, that is limit x tending to 0 minus, that is modulus x divided by x. We'll get minus 1 over there. Then we'll get a right hand limit, that is equal to 1 by writing all those things. Therefore, they are not equal. Therefore, it is discontinuous. Okay. Next, we have the 9th question. Let's see how we can do this and what is the difference between these two questions. So our aim is to first split the thing. But the difference between these two was that here only x is less than 0. Okay, I need not split or anything. I can just explain this at here itself. So x divided by modulus value of x. Always the modulus value of x is depending upon the sign of this. Since x is less than 0, it is going to be negative. That means that modulus value of x is equal to be minus x. Therefore, this whole expression is going to turn to minus 1 only. Okay. So f of x is equal to minus 1 for every x. For every x. See, that's what the thing. Nothing to do here. Okay. The thing was, when x is less than 0, I just evaluate the value of modulus value of x. When it is negative, the modulus value of x is going to be minus x. Okay, based on the condition. So x divided by minus x becomes minus 1. Therefore, this part also becomes minus 1. This is already minus 1. Therefore, the whole function changes to minus 1 only. Right? For every value of x, that means it is going to be a constant function. I am not at all bothered about the constant function. It is going to be continuous. I can write it as continuous at all its point. Continuous. That's all about the 9th question. Moving on to the 10th. Okay, now we have our 10th question set up. So up to the 12th question, it was given only to explain, find out which point is discontinuous. That means that we are not asked to prove whether it is continuous or not. We are thinking all in our mind itself. Only the point of discontinuity we are bothered in the questions up to 12. Later, based on the question, we'll see how it is. So now the 10th question is given like this. Since the extremity, that is a point, is going to be 1 only here. Okay. In all other cases, less than is given up, but here less than is given down. There is a kind of confusion created. So x is less than 1. There is not much confusion. You need to just tell that this is the left hand limit and this is the right hand limit. Okay. That's all the thing we need to care about, because you might interchange between the left and the right. When the examiner corrects, that time we feel that you are not seeing the question properly. Therefore, the left hand limit is based on this one. Okay, left hand limit. Therefore, limit x tending to, we are bothered only about the point x is equal to 1. Therefore, x tending to 1 minus x square plus 1. Okay, x square plus 1 is 2. Okay, I know how you to substitute and all. Now we think about the right hand limit. Right hand limit is limit x tending to 1 plus x plus 1. That is also going to be equal to 2. Then f of 1 is also going to be equal to 2. Therefore, no point of discontinuity. No point of discontinuity, or the whole function is continuous. In other words, I can write. Then you have the 11th question. Even the 11th question is very simple. We need to think about the point x is equal to 2. Left hand limit. Left hand limit is equal to the function at f2, f of equal to 2. That is equal to limit x tending to 2 minus x cube minus 3. That is equal to x cube comes to be 8. 8 minus 3 is 5. Then we have the right hand limit, that is going to be equal to limit x tending to 2 plus, then we have x square plus 1, that is equal to 4 plus 1, that is 5. Therefore, again, no point of discontinuity. Okay, that's all about the 11th question. 12th question again. Now we are bothered about the point x is equal to 1 here also. This is the most bothering point, I think. Now let's LHL. LHL is going to be equal to the function at that point, that is equal to limit x tending to 1 minus x raised to 10 minus 1, that is going to be 1 minus 1, that is 0. RHL is equal to x tending to 1 plus x square, that is 1. See, they are not going to be equal, right? 0, 1. Therefore, it is x is equal to 1 is point of discontinuity. Okay, next we'll see the 13th question. We'll read the question first. It is given, is the function defined by the given thing is going to be a continuous function? You need to just tell yes or no and explain how it is. Okay, now it's all about the explanation. The first sentence will be the dividing about all these two. When x is less than 1, it is going to be a linear function, that is x plus 5. Then when x is greater than 1, it is going to be a linear function x minus 5. In both the cases, in the given intervals, it is going to be continuous because it is a linear polynomial function. Okay, that's all about those two intervals. Now the remaining thing is about the x is equal to 1. T is going to be a point of discontinuity because it is not looking same also. Okay. LHL, RHL. Limit x tending to 1 minus x plus 5, it is going to be 6. Here it is limit x tending to 1 plus x minus 5 is going to be, that is 1 minus 5 minus 4. They are not equal. Therefore, x is equal to 1 is point of discontinuity. The same way you can write, or you can write it is the function is not continuous at x is equal to 1. Okay, that's all about the 13th question. Moving on to the next ones. Now we have 14 questions given in this form. Discuss the continuity of the function f, where f is defined in this form. Okay, while seeing this, you can understand that it is just limited to the interval 0 to 10. Okay, all the other part it is not defined. This function is not defined at all. So we are only bothered about from 0 to 10. When you consider the point that is extremities in this, that is 0, 1, 3, 10. Okay, those 4 extremities are there. When you consider the extremity 0 and 10, yeah, they are going to be applicable only to one particular condition. Right, here also when you consider the extremity 10, they are going to be applicable only to that particular part. Only one expression is considered. While in the case of 1 and 3, two of them are considered. When you consider 1, it is going to be 3 and 4. When you are considering 3, it is going to be 4 and 5. Okay, therefore we are bothered now only about x is equal to 1 and x is equal to 3. X is equal to 1 and x is equal to 3. What is the left hand limit? Okay, I am not going to write the expression. I will just write it is going to be equal. That is RHL. LHL, RHL. So the left hand limit of 1 is going to be this particular condition, that is directly 3. Right hand limit is going to be this particular condition, that is 4. Similarly, the left hand condition of x is equal to 3 is going to be 4. Okay. Similarly, the right hand condition is going to be 5. Therefore, both are not equal. Okay. Discontinuous at x is equal to 1 and x is equal to 3. That's all about this. Next we have the 15th question. So all this part is over. Next we have the 15th question. Here we have the interval. The extremities are only 2. We are not bothered like a finite one interval. It is fully infinite. Okay, now we have x equal to 0, x is equal to 1. Similarly, I think I can explain faster in this form. LHL, RHL. Since it's going to be equal in one of the cases, I am not bothered about the function at that particular point. So it can be equal to one of those limits. Okay. When it comes to be, I need to check whether it is continuous. At last I'll find out. If these are not equal, I am not bothered about that, right? So left hand limit of this x is equal to 0. Okay. The steps, I'm not bothered now. I am just going to write the value of 2x. Okay, the value of 2x when x is equal to 0, there is a little bit less than that, therefore it is going to be 0 only, right? Then when you consider this part, it is going to be 0, right? Then f of 0 is also going to be 0, therefore continuous at this point. Okay, you are not bothered, it's continuous. Next we'll go to the x is equal to 1 point. So the left hand limit is 0, the right hand limit, x is greater than 1. So this part should be considered, this condition. If you consider this condition, it is going to be 4 into 1, that is 4 only. Therefore, these are not equal, right? Therefore, discontinuous. Discontinuous at x is equal to 1. Okay. Similarly, we have one more question remaining under this topic. Now we have 2 points here also. That is minus 1 and 1. Minus 1. X is equal to 1. What is going to be the LHL? What is going to be the RHL? LHL, RHL. I hope you understood how to write the steps and all. So the steps I have not written. You need to write the limit x tending to 1 plus 1 minus 0 minus and all. That will take a longer time. I'll just explain this. So now we have to consider the left hand limit. It is going to be equal to -2 because this is the condition that is considered here. We have -2. Right hand limit is 2 into x. That is x when you are considering is -1. So 2 into -1 is again -2. Therefore it is equal. Then f of -1 is considered to be this form. Therefore that is also -2. Therefore it is continuous. Then you have that part when x is equal to 1. So when x is equal to 1, what it is going to be is 2 into 1. Left hand limit is going to be 2 because it is when x is less than 1. When x is greater than 1, right hand limit is going to be equal to 2. The value of that function is also going to be equal to 2. Therefore this part is also continuous. Therefore the whole function is continuous in the 16th question. Okay, we found out this part was discontinuous, this was discontinuous, here whole thing was continuous. There was no problem with this. And that's all about up to the 16th question.